Hi everybody, welcome to topic number 8 video, where we talk about the slope of a line. Here are our objectives today. We're going to find the slope of a line given 2 points of the equation. We're going to find the slope of the line given the equation of the line. We're going to interpret slope-intercept form in applications and different word problems. We're going to find slopes of horizontal and vertical lines, and then we're going to compare the slopes of parallel and perpendicular lines. So what is slope? We've all probably have heard of slope before and remember it from math class. We remember slope as rise over run. It's telling us how much we go up or down and then how much we run to the right. Remembering that for rise, if we go up, that signifies a positive value. If we go down, that signifies a negative value. And we always run to the right and represent it as a positive value. We always start with the leftmost point and work our way to the rightmost points, because when we read graphs, we read them going left to right. So for example, if I was looking at this line here and I wanted to find its slope, I would start at this point and I would see how high I could go. This point can go as high as here, so that would be 1, 2 up. And then from the right, we would go 1, 2, 3 to the right. This would mean this equation has a slope of 2 over 3. One of the other ways that we can do it is using algebra. We do have a slope formula for this. M, which is the letter for slope, can be represented as the difference in the y values, y2 minus y1, over the difference in the x values, x2 minus x1. So let's go back to the 2 points that we had over here, 0, negative 2, and 3, 0. All we need to do is just label these as x and y's, and it doesn't matter which one we do as which when we do this. So for this example here, I'm going to call this x1, which means this has to be y1, and then I'm going to call this x2, which has to be y2. So when I go to plug it in, it's y2 minus y1, negative 2 minus 0, over x2 minus x1, 0 minus 3. From there we see negative 2 minus 0 is negative 2, 0 minus 3 is negative 3, and 2 negatives make a positive. So either way, this comes out to be 2/3. For the most part, we will use an algebraic formula, especially if they don't give us a graph. If they have a graph, we can use this rise over run technique. But for the most part, we're going to use this algebraic formula to be able to go through and find our slope. So let's find some slopes. Find the slope of the line given the 2 points. And again, let's remember our formula. Slope, which is m, is the difference in the y's over the difference in the x. And again, it doesn't matter which one is x1 and y1, and it doesn't matter which one is x2 and y2. But one of the things that has to happen is that the 1's have to stay together and the 2's have to stay together. So if I call this one x1, this has to be y1. And if this is x1, this has to be x2, and this has to be y2. The slope in this case is y2 over y1, so 11 minus 5 over x2 minus x1, 6 minus 1. 11 minus 5 is 6, 6 minus 1 is 5. We cannot simplify that, so this slope would be 6 over 5. This is known as a positive slope because none of the numbers are negative. Let's do the same thing for b. Let's find the slope. Again, let's call this x1, y1, x2, y2. Our slope formula is y2 minus y1. Now be careful with this. It's y2 minus y1. So I'm going to say negative 7 minus negative 1. The negative on the 1 is not the minus sign. Those are two completely different things. There's always a minus sign when I do the slope. x2 minus x1 would be 4 minus 2. We could simplify a little bit of this because we know that what happens when we have two negatives, they become a positive. So this is really negative 7 plus 1 over 4 minus 2. Negative 7 plus 1 is negative 6. 4 minus 2 is 2. Negative 6 divided by 2 gives us a slope of negative 3. This would be known as a negative slope because the slope comes out to be a negative number. Find the slope of these 2 points. Now these are two special cases, and we're going to take a look and see why. If you look at the question for C here, look at the x's, x1 and x2. They are the exact same number, y1 and y2. Let's see what happens when I find the slope and the x's are exactly the same. Let's remind ourselves of the slope formula. M is equal to y2 minus y1 over x2 minus x1. So y2 minus y1 in this case is 5 minus 1. And the x's are the same, negative 4 minus negative 4. 5 minus 1 is 4. This double negative here becomes a positive. That leaves me with negative 4 plus 4. Negative 4 plus 4 gives me 0. We're going to come back to this problem in a second, but first, now let's look at D. D is kind of the same type of problem, but this time the y's are exactly the same. Our x's are different, but our y's are the same. What's going to happen to the slope when the y's are the same? So we're going to do negative 2 minus negative 2 at the top, and at the bottom we've got 5 minus 3. Well, the double negative here again makes this negative 2 plus 2. 5 minus 3 is 2, and negative 2 plus 2 is 0. So now when I look at both of these, one of these has 0 on top, the other one has 0 on the bottom. Which one gives us an answer of 0? Well, the correct answer is this one here. 0 divided by 2 gives me a slope of 0. But if you go and take a calculator and you try to put 4 divided by 0 in it, generally it comes out and gives you an error. That's because you can't divide by 0. So we call this slope undefined. You get an undefined value when you divide by 0 because you can't divide by 0. If the 0 is on the top, that's okay. So 0 divided by any number, we're going to get a slope of 0. Now a deeper dive into both of these problems. If I go back to C, let's actually go through and graph these 2 points and see what happens. Negative 4, 1 would be 4 to the left and 1 above. So my point's right here. And negative 4, 5 would be 4 to the left and 5 above. Right here. Well, if you connect the lines, you'll notice this creates a vertical line. So anytime the x's are the same, we're going to have a vertical line. All vertical lines have an undefined slope. So anytime we graph a vertical line, the slope will always come out to be undefined. Or another way to think of it, if your x's are the same, then your slope is going to be undefined. You could probably already guess what's going to happen when I graph D. We're going to go 3 and negative 2. And then we're going to go 5 and negative 2. And when I graph it, I get a horizontal line. That means that all horizontal lines have a slope that equals 0. So if you have a line that's horizontal, the slope will always come out to be 0. Or another way to think about it, if your y's are the same, the slope will always be 0. So, a great time for us to recap. There's 4 types of slopes that could happen. M, the slope, could come out to be greater than 0. That's a positive. That means that when we move from left to right, the graph goes up. It'll look something like this. If m is less than 0, or m is a negative value, then it is a negative slope. So from left to right, the graph is moving downward, similar to this. The other 2 types of slope are no slope and undefined slope. The no slope only happens when you have a horizontal line. So slope will be 0 if your line comes out to be horizontal. And the only way you get horizontal line is if your y's are the same. The last one is the slope being undefined. The only way we get a slope being undefined is if it comes out to be a vertical line. So any vertical line will have a slope that's undefined. And the only way we get a vertical line are if x's are the same. So these are the 4 different types of slopes we have: positive, negative, a 0 slope, and an undefined slope. Understand that a 0 slope and an undefined slope are 2 different things. An undefined slope will have 0 on the bottom, whereas a 0 slope will have 0 on the top when we go through and find the slope. Find the slope and y-intercept of each of these lines. So we got to go back and remember that lines are generally written in this format: y equals mx plus b. This we learned was slope-intercept form, where m is the slope and b is the y-intercept. So as long as these equations are solved for y, we should be able to find it. So for example, in A, y equals x plus 3. 3 will end up being the y-intercept. And this value here will be the slope. Now there's no number written here. We remember there's no number. It's really a 1. So the y-intercept in this case is 3. And the slope is just 1. For B, remember there's nothing added to it. The slope is always the one that's attached to the x. So this number right here represents the slope. The slope in this case is negative 1/3. And the y-intercept, since there's no number attached to it, is 0. For C, it's not solved in slope-intercept form, so we need to get it in slope-intercept form. We need to get y by itself. To do that, we'll go through and we'll add 3x to the other side. Y equals, and I'm going to put the 3x first, plus 9. And now this is in slope-intercept form, where I see the y-intercept is 9, and the slope is 3. Same thing with f. I got to go through and I have to solve this and put it in slope-intercept form. I got to move the 2x in order to get rid of the positive 2x. I'm going to subtract the 2x to the other side. Negative 9y is equal to negative 2x plus 36. Dividing everything by negative 9. Cancels out here and leaves me with y. Negative divided by negative makes this a positive, so this is 2 over 9x. 36 divided by negative 9 is negative 4. This is now in slope-intercept form, so now I can identify the y-intercept in this case is negative 4, and the slope in this case is 2 over 9. D and E are a little different. If you notice, there's only an x and a y, and if you remember back to when we did equations, we remember that x always happens if it is a vertical line. So if I wanted to go through and graph this, for example, at x equals negative 3, I would come over here and I would graph it, and it would look like this. Remember, all vertical lines have an undefined slope. So here, m is undefined, and it never crosses through the y-axis over here. So the y-intercept does not exist. There is no y-intercept for this one. Letter E only has a y. So we remember this is going to end up being a horizontal line. We do have to get y by itself to graph it. So I move the 4 to the other side, and I would get y is equal to 4. So as a line, it would look something like this. If it is a horizontal line, we remember that the slope of all horizontal lines is 0. And in this case, the y-intercept is 4. It's going through whatever equals it for y. So again, a great reminder, vertical lines always have an undefined slope, and they typically don't have any y-intercepts unless if it goes through the origin. And for a y by itself, it's a horizontal line where the slope is always 0, and the y-intercept just goes through the number that y goes through. Let's try to translate this and solve it with applications. When a roadside service truck is called, the cost of the service is given by this linear function. Y is equal to 2x plus 60, where y is in dollars and x is the number of hours the car has worked on. Find and interpret the slope and the y-intercept of the equation. So here is the equation, and we know what everything is. The 60 is the y-intercept, and the 2 is the slope. But what do these things mean? So let's think about it. If x was equal to 1, where x is the amount of hours they worked, we would take 1 times 2 and add 60 to it, and we would get 62. So for working 1 hour, it would cost $62. And I could do the same for 2. I would plug in 2 into where it says x, and I would still add 60, and I would figure out working 2 hours gives me $64. So what's happening is the 60 is never changing. So basically the 60 ends up being the flat rate. This is what they're going to get paid regardless if they work any hours. The 2 for the slope represents how much per hour they make. So if they work 0 hours, they're going to make $60 regardless. And every hour after that, they're going to make $2 more. Let's do the same for this problem. The amount of water in a leaky water jug is given by this equation, y equals 117 minus 10x, where y is the ounces and x is in minutes. Find and interpret the slope and the y-intercept. So again, we have this equation, and realize that this time it's kind of written backwards from our normal y equals mx plus b. The number next to the x is always the slope. So in this case, the slope is negative 10. And this now is the y-intercept at 117. But what does this all mean? So we know that it's a leaky water jug, and it's losing 10 gallons for every x. So for every minute. So the slope here is saying for every 1 minute, we lose 10 ounces of water. But what does the 117 mean? Well, again, if x was 0, so we haven't lost anything starting at 0, that means we started at 117. So our jug starts with 117 ounces in it. And for every minute we lose 10 ounces. So if x is equal to 1, if it's been 1 minute, it's now been 117 minus 10, or 107 ounces that are left. If x is equal to 2, it's 117 minus 10 times 2, which is just 97. Every minute, the jug is losing 10 different ounces. We can use slopes to talk about lines that are parallel and perpendiculars. We probably remember from geometry class, parallel lines never touch. They're always equidistant from each other. Well, the only way that lines can be parallel is if they have the exact same slope. So two lines that have the same slope will never touch, which makes sense. They're always going to move the same amount up or down and to the right, and so there's no way they'll ever cross each other. Perpendicular lines are lines that intersect at a 90-degree angle. So I should be able to go up and measure it and see that it is 90 degrees. In order for this to happen, we should be able to look at those slopes, and we should see the perpendicular lines have what's called opposite reciprocal slopes. So parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes, which we're going to take a look at here in a second. What does it mean to be an opposite reciprocal slope? What does opposite reciprocal mean? So let's look at it two ways. The first is opposite. If you're positive, then the opposite of that is to be negative. And if you're negative, then the opposite of that is to be positive. So opposite just means we're going to flip the sign. A reciprocal is when you flip the fraction. So for example, if I have 2/3, the reciprocal of it is 3/2. If I have 5/2, the reciprocal of it is 2/5. If I have 4 and I want to turn this into a reciprocal, we remember anything can be written as a fraction. So I can call this 4/1 if I want, and the reciprocal becomes 1/4. And if I had, for example, 1/6 and I wanted to flip it, it would just become 6/1 or 6. So an opposite reciprocal are both of these things happening at the same time. So if I had a slope, for example, that was 2/7, and I wanted to find its opposite reciprocal, well, it's positive, so now it's going to become negative, and I'll flip the fraction. 2/7 becomes 7/2. So 2/7 and -7/2 are opposite reciprocals. If I had -5/4, when I go through and take its opposite reciprocal, negative becomes positive, and 5/4 becomes 4/5. If I have 10 and I want to find its opposite reciprocal, again, remember, if it's not a fraction, you can turn it into a fraction by putting it over 1. So the opposite of being positive 10 would be negative, and the opposite of 10, or the reciprocal of 10, would be 1/10. Finally, I could do this one more time. If I had -1/13 and I wanted the opposite reciprocal, negative would become positive, and 1/13 would become 13/1, which is just 13. So an opposite reciprocal, we flip the sign and we flip the fraction as we do it. All of these values here would represent values of lines that would be perpendicular to each other. So when we're looking for parallel lines, we're looking for the same slope. And when we're looking for perpendicular lines, we're looking for opposite reciprocals. Let's do that here. We're going to determine whether each pair of lines is parallel, perpendicular, or neither. So again, what does that mean? We're looking for parallel. Are their lines the same? Are their slopes the same? For perpendicular, are their slopes opposite reciprocals? If they don't fall into either of these categories, then it's neither. So anything else falls into this. And to do this, we're really just going to go through and put all these equations in slope-intercept forms and look at the slope. So for example, when I look at A, it's already in slope-intercept form here. The part that I'm interested in is the slope, which is the value next to the x. So for this one, the slope is -3. The second line is not in slope-intercept form. We're going to solve it and put it there. In order to get y by itself, I have to take this 3x and subtract it to the other side. And then I would get y equals -3x minus 4. Now this is in slope-intercept form, and when I look at this line, it also has a slope of -3. When two lines have the same slope, these lines are parallel. So letter A, these would be slopes of lines that are parallel. Let's take a look at b. Again, the first equation's already set up y equals mx plus b. So I can go through and identify the slope. The slope here is 3 over 2. The second line, not set up. So let's solve it for y. In order to get rid of a positive 3, I have to subtract the 3 from both sides. Negative 2y is equal to negative 3x plus 6. Now I have to divide both sides by negative 2. Y is equal to, double negative makes this positive, so 3 over 2x. 6 divided by negative 2 is negative 3. Again, we're only concerned about the slope. We see that it also comes out 3 over 2. So these lines are also parallel. Let's look at two more equations. So here, none of these are in slope-intercept form. So let's change them real quick. Negative 2x plus 4y is equal to 1. I got to get y by itself, so I'm going to add the 2x to the other side. 4y is equal to 2x plus 1. I'm going to divide everything by 4. Y is equal to, now 2 over 4, we got to make sure we reduce that. 2 over 4 can reduce to 1 over 2x. This can't reduce, so the y-intercept is 1/4. So for this line, we get 1/2 as our slope. Let's go ahead and do the same for this line here. Let's solve it for y. In order to get y by itself, I have to subtract 6x to the other side. 3y is equal to negative 6x plus 3. I'm going to divide everything by 3. And I get y is equal to negative 6 divided by 3 is negative 2. And 3 divided by 3 is 1. So I notice here that the slope is negative 2. So we can see they're not the same, so they're definitely not parallel. The question is, are they opposite reciprocals? So if I take 1/2, which is positive, the opposite of being positive is negative. 1 over 2 would become negative 2 over 1, which is just negative 2, which is what I got here. So these lines would be perpendicular of each other. Again, be careful, because if I would have gotten m equals 1/2 and m equals positive 2 here, yes, these are reciprocals, but they're not opposite reciprocals. So if this would have been my answer, I would say that they are neither parallel or perpendicular. They're not the same. They're also not opposite reciprocals. In this case, they're just reciprocals. So make sure you be careful. When we work, we have to make sure for perpendicular that they're opposites and reciprocals. Now this is an interesting case here. We remember that if x is by itself, it's just a vertical line. So really, here is x equals negative 3. And y equals 5 is just a horizontal line that goes through at 5. So it looks like this. But we have a line that goes straight up and down. We have a line that goes straight left and right. They actually do form a 90-degree angle when that happens. So these lines would indeed be perpendicular. So if you have two lines that have just x and y, they will always come out to be perpendicular. If you have two of the same, if I had two x's, they'll never cross. Same thing if I had two y's, they'll never cross. So those would be parallel to each other.